Hi, let us proceed with our discussions on the testing of a beam in a heavy structure lab. In the previous videos, we talked about the test setup for a typical beam testing. You need to produce a beam specimen to be tested until failure in the laboratory. In order to conduct this kind of testing, you will need a set of instrumentations and equipments. The most basic one, you will need hydraulic cylinder and hydraulic pump in order to induce force onto the specimen. You also require some testing jig for you to simulate the loads acting onto the specimen. This includes the rockers and also rollers. And then you need the instrument to do some measurement. This includes the load cell that measures the load and LVDT that measures the displacement. These measuring instruments are connected to the data logger for data acquisitions. The data logger will record the data and display the results. You will need a digital camera to snapshot the conditions of the specimen throughout the testing. Now, this kind of test setup is known as the 4-point load test. The meaning of 4-point loads here include 2 vertical loads acting onto the specimen and 2 reactions given by the support. In total, there are 4-point loads acting on the specimen. You may also address this kind of testing as monolithic load test. It means that one single large load acting onto the specimen until failure. Sometimes we also call it as static load test. That means the load is applied at one single location throughout the testing without any movement. Now, this kind of beam are loaded with forces which increases gradually until the specimen failed. Now that you know the test setup already, let us proceed with our discussions on the test procedures. You know that testing a beam in the laboratory is a serious matter. Everything comes with cost. The load applying equipment, the measuring instruments, the data acquisition system, the specimen itself, as well as the facility in the laboratory. It is rather costly. Therefore, it is very important of you to conduct the testing carefully. Normally, when it comes to the large-scale specimen, due to the cost concern, the number of specimens will be minimized. You know that for a typical testing, if you want some good results with a higher level of confidence levels, normally 3 identical specimens shall be tested and the average value shall be taken. However, due to the concern in terms of the cost as well as the availability of the facilities, many researchers do not have this luxury to have several identical specimens to be tested. Very often, one type of design will have only one specimen. Now you have to be careful. If the test is not properly conducted and you have only one specimen, you might not be able to obtain a good result, and you do not have another specimen to check for inconsistency. And if you do not conduct the testing properly, this may affect your findings in your research study. And then you know that the nature of destructive tests is that the specimen can only be tested one time. By the time the specimen fails, the specimen already damaged. It is unable to return to its original states and conditions. Whatever you get for the data, you will have to abide to it. You are not allowed to modify any data. In the case that you suspect the specimen are not well tested, probably due to some critical flaws during the testing, you have to redo the entire specimen and then redo the entire testing. Casting an additional specimen will consume 1 month or more, and then you have to set up the specimens and redo the testing. This is time consuming. You cannot afford to have any mistake during the testing. So if you want to have good data, the testing has to be rigorously carried out. Now, how do you conduct the testing? One of the method is by referring to the testing standards, where this kind of standard will give you guidelines how to conduct the testing. Among the standards include ASTM, British standards, and others. Taking these ASTM standards for an example, the standard shall guide you through how do you conduct the testing. It clearly outlines the procedures, the test setup, the computations, the relevant dimensions, and even the calculations. It also provides you some information to be incorporated within the report. Normally, this kind of standards are quite thorough, and different standards shall give you different type of testing. There is a wide variety of these standards. Each standard shall have their own coding. By referring to the standard code, you should be able to find the relevant standards. This is an example for the ASTM. We have also British standards and others. The safest way for a researcher, especially for postgraduate studies, is that you conduct testing based on certain standards. Make sure you read through all the details. Follow the guideline accordingly. Sometimes, due to the complexity of the research, some test setup may not be available, or you are unable to find relevant standards from any sources, either due to the limitations of yourself, not aware of the existence of this kind of standard, or there is actually no such kind of standard. In this case, you may refer to the previous researcher, mimicking the process and conduct the testing accordingly. Or you may refer to some standards which may be different in terms of the test setup but have similar nature of the testing. You may adopt the testing procedures to be applied into your testing. You need to make sure that all the precautions as recommended by the standard, as well as the fundamental principles of having this kind of procedures in place, are not to be compromised. The ultimate goal here is to ensure the rigorousness of the testing, minimize the errors from the testing. In short, for research study, if you are conducting testing in the laboratory, your top priority is to abide to any standards. If you cannot find the relevant standards, you can refer to the standard of similar nature, adopt the principles and precautions for the respective standards, apply into your testing. Or you may refer to the previous researcher who used similar methods to conduct the testing. You are not recommended to conduct your own testing without referring to any references, as there are many minor things can lead to errors in acquiring the results. Now let us proceed with our discussions in terms of typical procedures of conducting testing. Different researchers might use slightly different approaches, but the concept and principle behind it are similar. Normally, before we start doing testing, we ensure the specimens are properly set up. Make sure the load frame and the support frame are properly installed. Make sure the instruments are properly functional. Make sure this kind of instruments has been properly calibrated, that the calibration date has not been expired, so that you can have reliable results. Before you use these instruments, you can do some simple check to see if the reading as given by the instruments are logical. Let's say this LVDT have a maximum stroke of 100 mm. So if you fully utilize that full stroke here, it should theoretically give you displacement of 100 mm. If you push the stroke here halfway, it should theoretically give you 50 mm. Before you actually conduct the testing, make sure the readings given by the data logger is logical. As for the load cell here, you can check the load capacity, and then you can try to apply some load onto the load cell to see the readings from the data logger. For example, you know the weight of yourself. By putting your own weight onto the load cell, theoretically it should give you the right reading. Although you are not recommended to do that, while doing this you have to be careful to avoid any unnecessary damage to the measuring instruments. I am not advising you to really stand onto the load cell just to test the accuracy of the load cell, but the principle is there. The best way of doing it is to make sure the calibrations are properly done and the calibration dates is not expired. This is about the checking before you want to start any testing. Sometimes you may install strain gauges on the reinforcement bar, which are embedded in the beam specimen. These strain gauges are also connected to the data logger. You may use the voltmeter to test the strain gauge, whether it is functional, and connect the strain gauges to the data logger to measure the strength. There are also strain gauges that can be placed on the surface of the member, measuring the concrete strength. Make sure it is also functional and properly connected to the data logger. Once you have all the measuring instruments ready, you need to go through a stage known as the pre-test stage. This is the stage that you prepare the specimen. Small loops is applied onto the specimen to consolidate the test setup and also to check the functionality of the measuring instruments. At this stage, the testing haven't started yet. So during this pre-test stage, knowing all the measuring instruments are functional, you set the readings to 0. There should be a button on the load cell for you to initialize all the readings, and then you will apply load to the beam. The load cannot be more than 10% of the estimated capacity of the beam. You don't want to fail the specimen, and you don't want to cause any undesired damage on the specimen as well. The purpose of applying this preload to 10% of the estimated beam capacity, it is to consolidate the test setup. The load should be maintained for 5 minutes. What does it mean by consolidating the test setup? Sometimes your specimen may have some connections. If the connections is not fully consolidated, when you apply load, the consolidation process will also go into the reading. This will disturb your result and lead to unnecessary noise in your results. Sometimes, if your testing frame is newly used, that means you install the testing frame, haven't been used to test any specimen yet. When you apply the force, the joints and connections may also consolidate. This may also lead to undesired movement of the testing frame that may affect your results. In a layman term, what you are doing now is exercising the specimen as well as the testing frame, making sure they are functioning well before you carry out the testing. Now you apply the 10% load for 5 minutes, and then you release the load. Leave it there for another 5 minutes. Theoretically, the member should recover to its original state, as you only apply very small load onto the specimen. You will expect the readings given by the data logger recover to 0 as the specimen returns to its original state. This one is for you to validate and check the accuracy of the measuring devices. Make sure these measuring devices are not giving you nonsense. So this entire process here need to be repeated twice. That means you apply the load to the 10% of the estimated beam capacity for 5 minutes, and then you release the load, leave it for another 5 minutes. Make sure no undesired movement of the test setup. Make sure the specimen is still placed in the right positions. Also make sure the measuring devices are functioning well, and then you repeat one more time. Once this pre-test stage completed, you are good to go. You are entering this testing stage. First, you will need to reinitialize the readings to 0. The data that you acquire here will not be put into your result. Whatever data you acquire after this shall be a part of your test result. Now you have initialized all the readings to 0. You can start applying the load. Press the hydraulic pump slowly so that the hydraulic cylinder induces force onto the specimen. You can set a constant interval of the loads and displacement. For example, 5 kilonewtons or 2 mm displacement. Now this interval, you will need to determine a suitable range. If the interval is too large, there will be less plot for the result. Then the response curve as acquired from the testing may not be as smooth. However, if the interval is too small, the reading becomes too refined. You have so many plots and it takes longer time for you to finish the testing. For us to determine the suitable range of the interval, normally we refer to the estimated beam capacity. My personal opinion, the numbers of plots should not less than 20 plots. In order to observe a good curve, if you want better refinement, probably you can estimate to have more plots, but not excessive. Let's say now your estimated beam capacity is 100 kilonewton. Then your load interval 5 kilonewton, it will be about 20 plots. You may even go to 30 or 40 plots, depending on your judgment. You're going to increase the load slowly. Reaching the interval, you will need to hold the load for 1 minute before readings is taken. The reason of holding the load for 1 minute is to ensure that stress are properly distributed throughout the entire member, that the entire specimen has fully consolidated before readings are taken. You will see slight fluctuations of the reading from the data logger as soon as the load is being applied. Once the reading stabilizes, that means the specimen is more or less consolidated. Then you may take the reading. Do not take the reading while the data is still fluctuating. This may affect your results. Once you're done acquiring the reading, you may increase the load to the next level.